So question 3, photograph shows the circuit, and you've got to draw the circuit diagram for this. So the first bit that we're going to do is the cells. There's 3 of them, so instead of you can do 3 cells, or you can just do a battery. The long end is the positive end of the battery, and next thing that you need in the circuit is an ammeter. And ammeters go in series with the rest of the circuit, and then we've got some crocodile clips and a wire. Now in the mark scheme it says it really doesn't matter what symbols you use for the crocodile clips and the wire, just as long as it kind of is obvious what you're trying to do there. The voltmeter goes in parallel with the component, so you can, the component that it's measuring the voltage across is the piece of wire, so your voltmeter needs to be in parallel with that. And that's enough to get you 3 marks. The things that they're looking out for is the correct circuit symbols for the voltmeter, the ammeter and the battery or the cells used, and the ammeter in series and the voltmeter in parallel. Next question about the variables, and the independent variable is the thing that gets changed in the experiment, and the dependent variable is the thing that gets measured. So we need to look back and work out what those are. So if you read what the investigation is all about, you can see that we're going to be changing the length, so that's going to be the independent variable, and we're going to be measuring the resistance. And you need both of those variables to get the mark. Now it's asking us to describe the method that we're using. It's a 5-mark question, which is a lot of marks. So to help us make sure that we've said the 5 things that we need to say, obviously we're going to use bullet points. So first bullet point, obviously we need to measure the length of the wire, and the thing that we need to do that with is a ruler. The next step is that we need to measure the current by using the ammeter for 1 mark, and measure the voltage by using the voltmeter for another mark. After you've measured the voltage and the current, the obvious thing to do is to calculate R, although in the mark scheme there's no mark given for this bullet point here, although I think it's part of certainly part of the method. After you've done that, you'll have 1 data point, so the next thing to do is to repeat the process for different values of the length. So you're changing the independent variable and making more measurements of the dependent variable. And another thing that you could do to test the repeatability is that you could take multiple readings of R for each value of the length. For example, you could take 3 different readings, and then you could take the average of those 3. And if you're trying to calculate the resistance, one of the things that you've got to do is make sure that the wire doesn't heat up too much, because if it does, that will affect the resistance. So you could turn the circuit off between those readings to avoid the circuit becoming hot. The equation linking voltage, current and resistance is V equals I times R. So if you're calculating R, then you need to do V over I, which is 4.5 divided by 0.7, which is equal to 6.4. Now when you did it on your calculator, you probably got lots more decimal places than this, but we're only quoting ours to 2 significant figures. Why? Because when we look up here, you can see that in the data table these variables are typically given to 2 significant figures, so it's sensible to quote our answer to just 2 significant figures, and obviously the units there are ohms. The next part of the question asks us to plot this on a graph. Now we've already identified that the length is the independent variable, and that means that this has to go on the x-axis. And likewise, we also said that the resistance is the dependent variable, so this has to go onto the y-axis. Then we need to look and make sure that we're getting a sensible scale. This goes up to 100, so we might be looking at 10 big squares for that one, and this one goes up to about 6.5 or 7, so we might be looking at 13 or 14 big squares for that one. Let's have a look at the graph paper, and we're going to try and maximize it on the graph paper. Okay, so the good news is that we have got 10 squares on the x-axis, so that fits on there easily. Okay, and we need to label the axis L for length and put the units centimeters. And likewise, it seems to fit, the y-axis fits perfectly. Okay, so we've got 13 big squares, so the scale fits on there quite nicely. And of course we need to label this axis as well, the resistance in ohms. As you can see, my graph isn't particularly beautiful because I've been trying to do it on a laptop. You of course are going to do it with a sharp pencil and a ruler. Next thing is plotting the points. First point is at 20 and then 1.3. Okay, so it's that point there. You can mark your points with a small x or a dot. I think that x's are the neatest way to do it. So there's the rest of my points plotted. In the mark scheme you need to get the points accurate to within the nearest small square. Okay, so you've got to be careful and accurate as you plot. And then finally there's my line of best fit. Again, you should be drawing yours with a pencil and a ruler. Okay, and if you've done it accurately, it should end up passing through 0, 0. So what conclusion can we draw? Resistance is directly proportional to length. And how does the graph support this conclusion? The reason that it does is because the graph is a straight line. The other way of saying that is that the graph has got a constant gradient which passes through the origin, or you can say it passes through 0, 0.